In this video, I'm going to talk about consistency and dependency of a system of two linear equations. So we want to solve the following systems of linear equations. We've got one which is consistent independent, and we've got another which is consistent dependent. We'll see what that means in a moment. But right now, let's just focus on the consistent independent system. That's x plus y equals 3 and x plus 2y equals 4. And the solution to that system is the point 2, 1. We can arrive at that solution through elimination or substitution. Either way, we'll get the same solution. Now let's think about what this system means graphically. The system consists of two linear equations, so it's really just two lines. And the solution is where the lines intersect. So let's go ahead and plot these lines. To make it easy to plot, let's just convert the equations to slope-intercept form. So solve for y in both of them. So the first one becomes y equals negative x plus 3 if we subtract x to both sides. And then the second one, let's do this in two steps. First of all, we've got 2y equals negative x plus 4, and then that turns into y equals negative a half x plus 2 once we divide by that 2 there. Okay, so let's plot that first equation there, y equals negative x plus 3. So it's a y-intercept of 3, and then going slope of negative 1. So over 1, down 1, and just connecting all those points there. So let's get our straight edge and connect those points, and that'll be the first equation there. Okay, now let's take care of the second one, y equals negative half x plus 2. So y-intercept of 2 this time, and slope of negative a half. So that means down 1 over 2, down 1 over 2, and same idea going this way. Okay, connect up those points. And where do the lines intersect? Well, they intersect right over there. And that indeed is the point 2, 1. Great. Now we call this system consistent independent. And what this means, consistent, just means that it has a solution. So consistent means has a solution. Okay, and then independent means that the solution is the only solution. There's only one solution. So let's write down, there is only one solution. Okay. Now let's take a look at the next system, x plus y equals 3 and 2x plus 2y equals 6. Why don't we try to solve this system? Let's just do substitution. So we'll solve for y in this equation. Like before, we'll get y equals negative x plus 3, and then we'll just plug that y in for this y here. So when we do that, let's write that down. So that becomes 2x plus 2 negative x plus 3 is equal to 6. Let's simplify that. So 2x plus, this is negative 2x, and then plus 6 is equal to 6. And 2x plus negative 2x, well, that's just 0. So we just have 6 equals 6. So we just end up with a true statement. What does that mean in the context of the solution of the system here? Well, it just means that the system has infinitely many solutions. The solutions are any point that lies on one of the lines. In order to lie on one of the lines, the solution must take the form x, and then we know that y is negative x plus 3, so just x and then negative x plus 3. So this has to be the form of the solution, where x is just any real number. So x could be 0. If we had 0, then the y-coordinate would have to be negative 0 plus 3, which is just 3. X could be 1, in which case the y-coordinate would have to be negative 1 plus 3, so just 2. X could be 2, then the y-coordinate would have to be negative 2 plus 3, so that's just 1, and so on. You could keep going. So there are really infinitely many solutions of this form, but this would be the general solution form. Okay, so this probably seems a little strange, but it's going to make a lot more sense if we think about this system graphically. So first of all, let's plot this line, y equals negative x plus 3. So again, that's just like last time, y-intercept of 3, then slope of -1. So going down like that, and we'll connect all of that up with the straight edge. So here we go, connect that up. And now let's plot the other line. So let's solve for y and the other line. So solving for y, we get 2y equals -2x plus 6, and then dividing by 2, y equals just -x plus 3. And hey, that matches up with the line that we had, our first line, and it also matches up with the solution. Okay, so it's kind of making sense why this is the solution, why all these points work. And if you plot this on the graph, again, that's just same y-intercept of 3, and then do the slope of -1, you get the same like exact points here. So you connect them up and you've really just got the same line. It's just overlapping the original line. So any point that lies on this single line is a solution to both equations because both equations represent the same line. Now we call this consistent dependent, and again consistent because it has a solution. 0, 3 is a solution, 1, 2 is a solution, 2, 1 is a solution. So again, consistent because it has a solution. But this time, it's not independent. There's not just one solution. It's dependent. There are infinitely many solutions. So dependent because there are many solutions. You can also remember it this way, dependent because the solution for y here depends on the value of x, and independent because the solution is fixed and does not depend on x or y. Here is a similar example, but this time the system is inconsistent, meaning it has no solution. Alright, but we want to attempt to solve this inconsistent system, and we're going to interpret the result graphically. So the system is 2x plus 3y equals 6, and 6x plus 9y equals 36, and why don't we do this by substitution again? So we'll just solve for y in the first equation. So we've got 3y equals -2x plus 6, and then divide both sides by 3, and we get y equals -2/3 x plus 2. And we can substitute that expression in for y over here. And when we do that, we get 6x plus 9 times that expression, -2/3 x plus 2, and that is supposed to equal 36. Okay, so let's see if we can solve this equation. So let's simplify first. 6x plus, what is 9 times -2/3? That's just -6, and then there's also an x, so -6x. And then plus 9 times 2, so plus 18, and that's equal to 36. Okay, so 6x plus -6x, that cancels out, that just gives us 0, and our result is 18 equals 36. But that's a false statement. 18 is not equal to 36, and no matter what we choose for x and y, 18 will still not be equal to 36. So there's no solution. No solution. And that means our system is indeed inconsistent. So no solution means it's inconsistent. Great. Okay, but now let's interpret the result graphically. So graphically, these are two lines, yeah, and don't two lines always intersect? What's going on? Well, it turns out it's not the case. It's not the case that two lines always intersect. And let's see by plotting these lines what that looks like. So first line, y equals -2/3 x plus 2, so that's a y-intercept of 2, and then going down 2 over 3, so down 2 over 3, down 2 over 3, and so we'll just connect these up with our straight edge. So let's go ahead and connect the dots here. Here we go. There is our line. And now let's take care of that second line. Let's plot that. So why don't we solve this for y? So we get 9y equals -6x plus 36, and then we'll divide both sides by 9. So just y equals -6/9 x plus 36 divided by 9 is just 4. And why don't we simplify this fraction? So y equals, divide top and bottom by 3, and you get negative 2/3 x plus 4. And let's go ahead and plot this. So y-intercept is 4 this time. And now we're still going down 2 over 3 according to the slope. Down 2 over 3, down 2 over 3. So it goes like this. Let's go ahead and draw that with our straight edge. And okay, we can see what's happening here. The lines don't intersect because they are parallel. Yeah, they have the same slope, they're parallel, and one is just shifted up from the other. So there's no way they're going to cross, there's going to be no points of intersection, and as a result, there's no solution. So that makes sense graphically. And now we have a pretty strong intuition for solving systems of two linear equations. In the future, we'll also learn how to solve larger systems, including 3 linear equations.